Question 8. Darts. At a fun fair, the booth of 3 darts offers 3 darts per game, 5 ringgit per game. And if you get a bullseye for 3 darts thrown in a game, you get a toy bear. The probability of hitting a bullseye is 7 out of 10, which is 0.7. So the question asks, Part A, by spending 30 ringgit, Bob would play the game if he had 90% chance to win at least 1 bear. So he needs to win at least 1 game. So to calculate to suggest whether Bob should play the game or otherwise. Then part B asks, what is the minimum number of games he has to play so that he can win 4 toy bears? Right. So for part A, this is actually not about bears and darts. This is just about probabilities. So question 8. So we consider first a game. So a game, you have 3 throws, 1, 2, and 3. And if you hit a bullseye for each of them, you get a toy bear. Or we say that you have won the game. So let's first consider the numbers that are given. The probability of a bullseye. So that's B for bullseye. Okay, so the probability for a single throw is 0.7. So the probability of winning a game, so we'll call that a win game. Right? To win a game, you'll have to have 3 bullseyes, which is the probability of having 3 bullseyes, and that is 0.7 cubed, and that's 0.343. So of course that we know that 1 win means 1 teddy bear. Okay? And the probability of losing a game, which is, L stands for lose game, just 1 minus the probability of winning. So 1 minus 0.343, and that is equal to 0.657. Now, the question says that if you're given 30 ringgit, and it's cost 5 ringgit per game, so 30 ringgit translates to 6 games. So, if you play 6 games, so you have 1, 2, 3, 4, 5, 6 games, and each game has 3 throws. The question is, what is the probability of winning at least 1 of these 6 games? So the probability of winning at least 1 of these games, which is, let's call it more than or equal to 1 win in 6 games. So G for games is equal to 1 minus the probability of losing in all games. So which is 6 losses in 6 games. 6 losses in 6 games actually means you lose every one of them. So that's just L 6 times. So that would be equal to 1 minus. The probability of losing 1 game is 0.657. So the probability of losing 6 games in a row is 0.657 to the power of 6. And if you work that out, the answer is 0.9196, which is just slightly over 90%. So the conclusion is, therefore, Bob should play. And that's the answer for part A. For part B, the question asks, what is the minimum number of games he has to play in order to win 4 bears? Now, if Bob is extremely lucky, the minimum number of games to win 4 bears is just 4. Because if he's extremely lucky, he would win every one of the games that he plays. So that's equal to 4. And that's your answer for part B. So there's no mention of probability here. It's just the minimum number of games to win 4 bears. And the answer is 4. And that's it for part B. Then question 8. Thanks for watching.